All right, chillins and chickadees, this is our introduction to Chapter 4. Now, in Chapter 4, we're going to be talking about several different items, but specifically ratios, and then we're going to get into rates, and we're going to get into unit rates. So maybe you remember me talking about ratios very briefly when we looked at our Chapter 2 and we talked about fractions. We talked about improper fractions, and I said we're always going to change those or convert those into mixed numbers unless it's a ratio, a rate, or a unit rate. So what exactly is a ratio? Well, the first thing we need to understand is a ratio can be written in three different ways. Now, I commonly write my ratios in what looks like a fraction form because that's the original way that I was taught. However, there's three different ways in which we can write them. And as we're writing them, and we'll be going through it then, I also need to understand that what I'm doing is I'm comparing two things. Now, one of those things could be the whole, out of the whole group that we're talking about, and we'll look at some examples for that. So as we're going through it, we're talking about ratios, we're not talking about fractions, even though one of the forms, like this right here, looks like a fraction. It's not. It is indeed a ratio, because if it wasn't, then I would have to change that to a whole number of 10, and that's going to mess me up completely. So ratios are not difficult. This should be a pretty easy lesson to really understand once we accept that might be something new and some of the terms might seem really weird compared to, I know that's a fraction and he's saying it's not a fraction, but if you're open to it, your mind is engaged, you're following along, you're going to do just fine. So I have a couple of examples to begin with, just so you understand our concept that we're talking about that aren't in your book. Now, one of the things I also have to understand with ratios is it's going to be asking me a comparison of two things, and at least two things. And I always have to put them in the order in which it's asked. So notice on this one it says, how many monkeys to bananas? Well, first I have to know exactly what it's talking about, so we'll put some monkeys and bananas up there. So when I ask about how many monkeys to bananas, then I have to start with the number for monkeys, and then end with the number for bananas. How many monkeys are there? 1, 2, 3, 4. 4 monkeys. How many bananas? 1, 2, 3, 4, 5. 5 bananas. So when I write it then, and we said there's three different ways to write it, then I have to be able to put them in the order in which they're asked. So as I said, I always start with fraction, which is what I learned first, but there's three different ways we can write them. But it's important. Now, you don't have to have those labels there, but I'm just showing you that because monkeys is listed first, it's going to go on top. And because bananas is listed second, it's going to go on bottom. What has to be is the numbers in the right order and the correct numbers, and you all can count, so you're good to go there. So I know I do have 4 monkeys to 5 bananas. Another way to write it then is with a colon. So I can write it as 4 to 5. Now here's the thing. If me showing you this, you automatically think of 4/5. And you can't get 4/5 out of your head. Even though now we're talking about ratios, then don't use it. The only time you have to use it in this form is if the directions say to show it, your ratio, as a fraction form, or 2, it says, here is what I want you to find, list all 3 ways to write a ratio, or 3, it says, here's 1, and I want you to write the other 2 ways. All of those will come up as we work throughout the remainder of the year. If it just says a ratio and the fraction form of the ratio confuses you because you think only of fractions, don't use it that way. Use the colon. The other way to write it is with the word 2, 4 to 5. Here's the thing. All 3 of them are said the exact same way. All 3 of them are said 4 to 5. This is said 4 to 5 because I know it's a ratio and not a fraction. This is said 4 to 5. And this is said 4 to 5. Now, the other aspect is we can switch those. Notice I have bananas now first, followed by monkeys. I know that there are 5 bananas and there are 4 monkeys for previous, so that just means that my answers when I write them as ratios should look, well, completely opposite, right? So notice I'm going to have now 5 bananas over 4 monkeys. Here's one of the biggest reasons that these are not fractions but ratios. In fractions, I would have to convert that to 1 and 1/4. which doesn't make any sense whatsoever when I'm comparing bananas to monkeys. I'm ignoring that, and hopefully it'll go away. So then, if this says 5 to 4, you don't like it in fraction form, you have two other options. You can do the colon, 5 to 4, or you can do the word, 5 to 4. Understanding that all three ways to write the ratio is said the same way. They all say 5 to 4. Well, we don't have to use just monkeys and bananas. We can use shapes also. So I have, it's kind of like Lucky Charms. I have red circles, blue stars, green triangles. And it's going to tell me what they want me to compare. So let's start with the idea of comparing red circles to blue stars. So I know the order that the numbers have to go in. However many red circles there are has to be my first number or my top number. And my second number has to be however many blue stars there are, or it'd be my bottom number. So how many red circles are there? 1, 2, 3, 4, 5, 6. Compared to blue stars, 1, 2, 3, 4, 5. So I know that my ratio is 6 to 5. Or if you don't like it in that form, then I can use one of the other two. 6 to 5 or 6 to 5. If the directions say write all three ways, you have to show me all three ways. Each of those will be worth a point. Another way that a ratio will work would be comparing an item to a whole group. So my question could say, if I can get it to come up, there we go, green triangles to all of the shapes. Now here's the most common mistake that my sixth graders make. They read this as all other shapes, and the word other is not in there. Because generally what they do is they figure out that there's 15 shapes there, and they subtract 4 from it, and they put 11. It's not the way the question is worded. If they want you to compare it to all other shapes, then that's what they'll say. This says all shapes, so I know I have to take my green triangles, which is 4, and compare it to the 15, which is all of the shapes that are there. So I have 4 to 15. Or I could use the word 2, 4 to 15, or I could use 4 to 15 with the colon. Any of the three, as long as it only makes you write it one time. I could switch those also and do all of the shapes compared to the green triangles. Any order is okay because I know which way to write them. All of the shapes is 15, so it's just going to go on top or be first. This would be 15 to 4, or 15 to 4, or 15 to 4. We can also look at people. You have 3 sixth grade teachers. You have 67 sixth graders. The ratio could be, well, what is the ratio of teachers to students? That would have 3 over 67. All three ways would be 3 to 67, 3 to 67, or 3 to 67. They could ask, well, what is the ratio of students to teachers? So flip-flopping those. And all I do is turn it upside down. 67 to 3, 67 to 3, or 67 to 3. Okay. So we have the basic ideas, right? So I've covered everything that you really need to know, but just going over it. These are ratios and not fractions. And ratios are always going to be comparing two items. And when I'm comparing two items, one of those items can indeed be the whole group. I have to make sure that I know which order they go in. When I say a ratio, I'm always going to say the first item or the first number to, the word to, the second one. And there are always 3 different ways that I can write a ratio. I can write it in with the word to, or in what looks like a fraction form, or with the colon, all of which are going to be said, the first item to the second item. So that's your basic introduction of everything that this lesson is about, but now we have to practice it. So I need you to be focused, and I need you to be engaged, I need your ears to be open, and I need you to be taking notes. Please follow along as we go through this. So in our book then, we start here on chapter 4, lesson 1. And it gives us this scenario with Julie and Beth. And it says that Julie makes 3 bracelets for every 1 bracelet that Beth makes. So they're showing with counters 3 counters for Julie and 1 yellow one for Beth. And it simply asks to begin with, well, what is the ratio of Julie to Beth when it comes to making the bracelets? Well, for every 3 that Julie makes, Beth will make 1. Now that could be shown in any of those 2 other forms also, but it gives you the colon, so we just use that one. Once I have that then, it adds you this on. So we're going to be able to take our ratios and we're going to be able to build upon it, which you'll see here in some of these practice problems that we get to. This says, model the ratio that shows the number of bracelets that Julie makes when Beth makes 2 bracelets. Write the ratio and explain how you modeled it. So I have to model it. I have to have something over there. Now you could put R's for red and Y's for yellow. You could put J's for Julie and B's for Beth. I don't care how you model it. I just inserted the circles that they did. So I know my original one was that I have 1 yellow with 3 red. And then it says, well, she's actually going to make 2 of them. So Beth has now 2 bracelets. And for every 1 that Beth makes, Julie makes 3. So I know that that ratio becomes a ratio of 6 to 2. Well, I explain how I did it. Well, I added another yellow for Beth, which added 3 more red for Julie. And then when I total them together, I get 6 red, 2 yellow. All right, so then it says, how could you change the model from part B to show the number of bracelets that Julie makes when Beth makes 3 bracelets? Write the ratio. Well, it doesn't tell me to go ahead and model it, but it does ask me how I would do it. And I would just add another yellow for Beth, and that would mean I'd have to have 3 more for Julie. Well, what would that ratio become then? Well, that ratio, if I had, notice I kept this original 3 here, so that would be the scenario that we're talking about. Then I would know I have 9 to 3. Or you could write with a colon 9 to 3, or in the fraction form, 9 to 3. So let's look at the practice problems that they give us then. So we have this practice problem says, write the ratio of yellow counters. All right, so yellow counters means I have to start with yellow. And how many yellow are there? There's 1. And how many are left? There's 2. So my ratio would be 1 to 3. Should be 1 to 2. I apologize. There's 1 to 2. Changed it. No. On number 2 then, my yellow, I wrote it all 3 ways. It doesn't say to write all 3 ways, but you can use it in any of the 3 ways that you would like. They used a colon here. You could use the colon. You could use the word 2, or you can show the fraction form of the ratio. But you have 5 yellows, and you're going to compare it to what's left, which is 3 reds. So it's 5 to 3, or 5 to 3, or 5 to 3. Now, on 3 and 4 then, it says to draw a model of the ratio. So, I'm thinking about Wednesday's field trip that we're going to go on. When we go to the poop plant, there's a lot of laughing by adults going on. Why? Because you're looking at poop and some of your faces get rather disgusted. Okay? So we can use emojis, we can use shapes, we can use whatever we want, we can use letters. It's completely up to you, as long as you're showing me a ratio of 3 things to 2 things. Kind of like with number 4. It says compare 1 thing to 5 things. And what I thought about was the Justice League. You have Wonder Woman, the one woman in the entire group, all by herself, surrounded by the 5 guys on the team. You have Cyborg, Batman, Superman, Flash, and Aquaman, all supporting her also in the Justice League. So this would show 1 female compared to the 5 males on the Justice League. You can show any forms that you want, as long as they're appropriate and make sense, but that you're showing me items that are 1 to 5. This one we haven't looked at yet. It looks really complicated, I'm sure, but I promise you it's not, as long as you do it step by step exactly how I'm going to show you to do it. So Wen is arranging flowers in vases. For every 1 rose she uses 6 tulips. Complete the table to show the ratio of roses to tulips, and then they show you, here's the column for roses, and here's the column for tulips. And they say for every 1 rose, we have 6 tulips. So they start you out with 1 to 6. This is a ratio box, because I have the ratio of 1 to 6 in the fraction form. If I'm going to 2 roses then, well, what did I do to the 1 to get to the 2? Well, I multiplied it by 2, right? So if I'm multiplying 1 by 2 to get 2, then I have to multiply my 6 by 2. And 6 times 2 gives me what? Gives me 12. So it should make sense that for every 1 rose, I end up using 6 tulips. So if I have 2 roses, I'm going to have 12 tulips. All right? Well, what about the 3? Well, what did I do to the 1 to get the 3? Well, I multiplied the 1. Notice I went back to my original ratio here. I multiplied the 1 by 3, and therefore I have to multiply the 6 by 3. Because with fractions, we said, whatever I do to the top, I have to do to the bottom. Ratios work the exact same way. If I'm going to multiply up here by 3, I have to multiply down here by 3. So 3 times 6 gives me 18. All right. My last one I have is a 4. And in order to get that 4, going back to my original ratio, I take my 1 and multiply it by 4, which means I'm going to multiply the bottom by 4. And 4 times 6 gives me 24. So I filled out this entire ratio chart showing my table by every row that I increase by 1, I'm increasing by 6s. Now notice the next ratio table. It's a little different, isn't it? It doesn't just give me a straight row. So I have to figure out what I'm doing to either the top number or the bottom number to get the next number. So what I mean is, like here we have students to adults. On the 6th grade field trip, there are 8 students for every 1 adult. Complete the table to show the ratio of students to adults. So for every 8 students, I have 1 adult. But now I'm going to say I have 2 adults. Well, what did I do to the 1 to get the 2? Well, to get the 2, I had to multiply by 2, which means I have to go to my students, and I have to multiply it by 2 as well. And 2 times 8 gives me 16 students. But now I have students. Well, that's okay. I know I have 24 students, so I go back to my original ratio. What did I do to the 8 to get the 24? Well, I'd have to multiply it by 3. So therefore, I have to multiply the bottom by 3. So how many adults does that give me? Well, 1 times 3 is 3. Should be easy enough. Well, what about the 4? Well, what do I do to my original ratio that's straight across here to get the 4? Well, I have 1, so I have to be multiplying it by 4, which means I have to multiply the top by 4. And 4 times 8 tells me I have how many students? 32 students. So it's just fill it in the chart with a systematic way of doing it. And each time I'm just showing these little multiplication steps, knowing how I'm increasing as I go along. So that's really all there is to ratios. Shouldn't be difficult. I did a lot of explaining and showing only because I really want you to understand it. So ratios are not fractions. They're going to compare 2 things. One of those things can be the whole number. They always have to go in the order that they're asked about in the problem itself. I'm always going to say this number to this number, because that's the way I say them, even though there are 3 ways I can write them. Either in a fraction form, I can use the word to, T-O, or I can use the colon in between the 2 numbers. So your assignment is going to be 215. I'm going to do 2 through 10. 10, you're going to have to put forth a little bit of extra effort, but I know you can do it. And then 216 is going to be the 2 at the top that are a similar problem, and then the 4 that are review. So if you have any questions, then all you have to do is ask, and you will get the help.